you guys is, what is a factor? Now, second hour sat there for quite a while pretty quietly before we came up with the definition. And so then I gave them an example. I told them 3 and 2 are factors of 6. So at your table right now, I want you and your partner to either come up with, and yep, you can partner up across the aisle, what is a factor if you have a definition for it, or at least be able to give me some examples of factors. All right? Hands down, Davis, I'm not calling anyone. I want you at your table to talk to that person next to you and come up with a definition. Or examples of factoring. Keep up with examples.
3 now. 3 things.
Alright, what do you come up with for your example?
10 and 2 are factors of 20.
Do we agree? 10 and 2 are factors of 20. Beautiful. Right, example or definition? Alright, let's see what they've got for a definition. Ooh, I like it. You're really close. We're not going to use the word multiples. They're really, really close to it. Like 12 is a multiple of 6. 20 is a multiple of 10. You guys are on the right track. You're on the right track. This is, how many of you have used these words since like 5th grade? A little bit in 5th grade, but we don't use them a whole lot in middle school, do we?
No.
All right, someone had their hand up back there. I thought I saw. Davis, did you have your hand up? You're really, really close. What is a factor?
An example, so help me know what the definition.
Yes, give me another example. You had your hand up.
Like for 50, 25, 2, 5, and 10, all factors that go into 50 besides itself in 1.
Did anyone hear the key word he just said there?
I thought you didn't know the definition.
Factors, and then he also said that they go into. What word would we use for going into? What math word would we use?
Input.
Not input. Chandler?
Multiplication.
Not multiplication. What's the opposite of multiplication?
Divide.
Division. They are numbers that divide.
Are we supposed to write this down?
What do you think?
Yeah. Where at?
Thank you, Bree. That divide into a given number. So 2 and 3 are factors of 6 because 2 and 3 multiply to give me 6. But also 2 and 3 divide into 6. All right. The definition that second hour came up with is it's numbers that multiply together. And that's where that word multiples is so close to what we're thinking of. It's numbers that multiply together to give a specific product. Now, you don't have to write both of those down, guys, but that was where they were looking at. And that's why when those of you who are using the words multiple, I knew where you were headed with that because we multiply them together to get a specific product. What's the greatest common factor then, guys? Liza?
The 2 biggest numbers that multiply together.
Yeah, the largest numbers that go into your product, okay? What we came up with is it's the largest number that divides into a set of numbers. We started out by saying the word pair of numbers, and then someone looked ahead on their notes, and they looked at the last problem on there, and how many numbers are in that last problem, ladies and gentlemen? 3. So we realized we can't let our definition of greatest common factor be limited by just a pair of numbers. We're actually going to be going beyond that. All right, ladies and gentlemen, does everyone have what they need on here? Can we actually start getting into some of the meat of the lesson and some of the work that we're beginning to be doing today? You're not finished yet? All right, ladies and gentlemen, I know some of you are going to be top notch at this, ready to go. What I'm showing you is nothing new because you learned your multiplication facts really quickly in like 3rd and 4th grade and you're really good at multiplication. Some of you didn't, and that's okay. All right? I have a daughter who whipped through them in 3rd grade, never even knew you studied multiplication. My other daughter, we studied multiplication flashcards 4th and 5th grade. All right, guys, we're still working on it. And that's okay. So what I'm going to model is not necessarily the work I need to see, but I'm modeling strategies that you need to use when you can't find them. Does that make sense, ladies and gentlemen? I'm also trying to set you up for good habits for what we're going to start tomorrow and what we're going to work on Friday and what we're going to do again after spring break. So it's kind of like we've always done in here. If you're asking Mr. Clem and I for help, the first thing we're going to say is, what are the factors of 12? Write them out. Does that make sense, guys? So if you can answer the question, what is the greatest common factor of 12 and 24, and you get that right, then you probably can stick with what you're doing. Okay? So here we go. Chandler, I hope I gave you enough time there, right? Oh, beautiful. All right, 42 and 60. We need to find the greatest common factor for those two numbers. And so to give myself a good strategy for that, I start with the smallest number. And what I'm going to do there is write down all the factors of 42. But I'm not random about how I do that, guys. I'm very specific because I don't want to leave anything out. So I start with the smallest factor of 42. And that's 1. 1 times 42 gives me 42, right, guys? I write them down in pairs of factors. After 1, I would try 2. Does 2 divide into 42? Yeah. How many times? You can't answer that. Do you have a tool that will help you? Well, yes. Actually, take the time to divide it out. 42 divided by 2 is 21. Does 3 divide into 42?
Yeah.
14 times. Does 4 divide into 42? No. Does 5? No. Ladies and gentlemen, should you even need to try that one on your calculator? No, because what doesn't it end with? 0 or 5. Those are the only things we do with 5. Does 6 go in there? Yeah, 6 goes in there 7 times. And guess what, ladies and gentlemen? I'm done. I've found all my factors. How do I know that? Well, ladies and gentlemen, what would I try after 6?
7.
7. And is 7 already on my list?
Yeah.
Yes, I'm done. You don't need to try 8. You don't need to try 9. You don't need to try 10. So if you go in order like that, ladies and gentlemen, you're not going to leave anything out. And you're not going to spend a lot of time trying things that don't work. Does that make sense, guys? So that's why being neat and organized and having a pattern to your work makes sense. Well, now I need to find the largest number in this group that divides into 60. Now, does 42 divide into 60? Hopefully most of you said no. Is 21 going to divide into 60? No. Does 14 divide into 60? Well, at some point, ladies and gentlemen, if I'm not sure, what am I going to have to do?
Calculator.
Grab your calculator. But no, 14 doesn't. Does 70? Or I'm sorry, does 7 go into 60?
No.
No, because 7 times 9 is 63. Does 6 go into 60?
Yes.
Yes, so I just found my greatest common factor. I'm done. Now, it may take a little bit of time, ladies and gentlemen, but what I've done now is I've narrowed it down to a lot less guessing and checking. Does that make sense?
Yeah.
All right. 36 and 64. I will tell you second hour I got this wrong because I missed one of them. Or this one, or maybe number 3 that we missed there. 36, or is 1 and 36? Does 2 go into 36? 18 times. 3 goes in there. 12 times. 4 goes in there. How many times? 9 times. Does 5 go in there? No, we're not even trying 5, are we? Does 6 go in there?
6 hard.
And you're done. When you find a pair that's the same, ladies and gentlemen, you've exhausted all your options. You don't need to try 7. You don't need to try 8. So now I need to go through there and find which of those divides into 64. And once again, depending on how strong you are with your multiplication facts, you're going to be able to find it a lot more quickly than others. They make us usually memorize through 10, correct? Some of us have to memorize our multiplication facts through 11 and 12. But if we're not confident, take your calculator. Do 64 divided by 18. Do 64 divided by 12. but the largest number that divides into 64 and 36 is 4. Because, ladies and gentlemen, I'm not starting at this side of my group. Guess where I start at? I start at 36, and I work my way through the largest numbers. Does that make sense, guys? Because I want to try to find the largest. I start at my largest numbers and work my way around this group. Do you also see why I write them in order, guys? Okay, I am kind of picky about things, but does being picky and being neat sometimes help? Yes. All right, even if you don't agree, you know to say yes. All right, 24 and 81. What are the factors of 24? 1 and 24.
2 and 12.
2 and 12. 3 and 8. 4 and is 5 going there?
No.
Nope. And so we're done, right? 6 is already on our list. All right, we need to find numbers that divide into 81. Huh. I've got some people sleeping. Open up your eyes. Do jumping jacks. Can you tap him? Something. Take your jacket off. Take your jacket off if you want. You don't need to wear it. All right. So, ladies and gentlemen, what's the largest number? So, Austin, did 24 divide into 81?
No.
If you haven't tried it yet, then do it. Did 12 divide into 81?
No.
Did 8 divide into 81? 8 doesn't divide into 81. What does 8 divide into? 80. Did 6 divide into 81? What about 4? No, because 4 divides into 80. Does 3 divide into 81?
Yes.
So, ladies and gentlemen, I had a whole group of some pretty large numbers there. Did I end up with a pretty small answer there?
Yes.
Yes. But I'm confident in my answer because I eliminated all the other possibilities. All right? Does this look familiar from 5th, 6th, 7th grade, guys? Great. Going through the list of factors here? Okay, I did 4, right? And 4 times 6 was what I wrote there. Did 5 work?
Attention, please.
So, ladies and gentlemen, let's take a look at the stuff we're really adding new here, and that's with these polynomials. Now we have, we have a monomial, and we're including variables. So we're going to do the same thing that we did. We're going to take 32 and 48. We're going to ignore the variables for right now. We have 1 and 32, 2 and 16. 3 doesn't divide into 32. 4 goes in there 8 times. 5 doesn't work. We know that. 6 didn't divide in there evenly, and 7 didn't divide in there evenly. Is 8 already in there? So I'm done. Have I found all the factors of 32?
Yes.
Yes. All right. Which of these is the largest number that divides into 48? Does 32 divide into 48? No. Does 16 divide into 48?
No.
Try it. Do 48 divided by 16. Don't tell me no unless you've tried it. Oh, what's 48 divided by 16? 3. Does it work? Yes. Use that calculator. Ladies and gentlemen, I'll be honest. I had to do some of the division this morning because I just said we learn our multiplication really good through 10, right? And then some of us learn our 11s and 12s. I don't know my 13s very well, ladies and gentlemen. And my 14s and 15s I'm decent at. But definitely my 16s and 17s I don't know. So I've got to grab my calculator to divide by 16, to divide by 17, to divide by 18. So are we okay with the 16 here? All right, now we need to look at variables. X to the third means x times x times x, correct?
Yeah.
X to the fourth is x times x times x times x. Write this down now. Because when you get home and have to work on this, ladies and gentlemen, you need something to look back at how we did it. Yes, once again, that's why you write it down. How many x's do they have in common? 3. So our greatest common factor is x to the power. All right, 18 and 48. 1 and 18. 2 and what? 2 times what is 18? 9. 3 times 6 is 18. 4 doesn't go in there. We're not going to try 5. And 6 is already on the board, so we found all our factors. Yeah. Does 18 divide into 48?
Yeah. No.
Does it? Test it. Do 48 divided by, I don't think it can because 16 divides into 48, but double check it. It's 48.
What?
48 divided by 18, did it work?
No.
No. 9 doesn't divide into 48, but does 6 divide into 48?
Yes.
All right. I've got 5 p's here. That's what p to the 5th means. How many p's do I have here? So how many p's do they have in common?
6.
4.
Write it out. 5 p's, 1 p. How many p's do they have in common?
Oh, wow.
So 6 feet.
6 p. Ladies and gentlemen, what was the smallest exponent out of these two, Rachel? What was the smallest exponent out of the two variables in number 1? The smallest exponent in number 1.
2 and 16. 40.
No. The smallest exponent in number 1. 3. What was my GCF? 3. What was the smallest exponent between p to the 5th and p? 1. What was my greatest common factor?
1.
1.
Wait, is that, so that's,
Well, let's see. We have a pattern with the first two, correct?
yeah.
Here we go. 13. Ladies and gentlemen, 13 is one of my favorite numbers. Does anyone know why I like 13 for factoring? It's prime. So what are the only factors of 13? 1 and 13. All right. Does 13 divide into 52, ladies and gentlemen? How many times does 13 go into 52? 4 times. So that means 13 is the greatest common factor. Now I need to look at my t's. I've got 3 t's here. How many t's do I have here? 1. How many t's do they have in common?
1.
What was my smallest exponent between these two?
1.
So Austin, is our greatest common factor always going to be the smallest exponent?
Can I ask
Yes.
a question?
Yes.
How did you get 6 for?
Because I took 48 divided by 18. It didn't work. No, it didn't work. I took 48 divided by 9. It doesn't work. It's not a whole number. I took 48 divided by 6. It works. And so 6 is your greatest common factor.
It might help some of you, and there's a lot of just sitting and looking, and sometimes people learn that way, but being on your calculator and confirming that it works, saying how you do that, because that's the question that Cam's asking, he's typing it in and taking 48, dividing it by 9, and getting the decimal. It will help to see, oh, that didn't work. I gotta keep going to the next smaller number.
Some of you are just sitting there waiting to get the answers, and that's fine. But like Mr. Clem said, until you physically start doing it, you're not going to know, well, how did we get 6? How did we get 16? We're getting it by taking these factors and dividing them into the larger number. Cameron.
So once you divide 40, so once you divide whatever 48 number you got, divide that number, it goes to get you 18. The number on the side right there. I'm confused about what you're saying. I'm confused.
I need to find the greatest common factor between these two numbers.
Yeah.
So I list all the factors of 18.
Yeah.
These are the only possible common factors they can have,
Uh-huh.
because these are the only numbers that divide into 18, right? I don't list 48 because 48 is going to have some factors that are bigger than 18. And I know there's no way to take a big number and divide it into 18. So that's why I started with 18. Do you understand how I got these numbers here? Are we confident with that?
Yes.
All right. So now to find the greatest common factor, I have to, remember, a factor is something that divides into another number, right? So I have to figure out which of these numbers divide into 48. So that's exactly what I do with my calculator. I do 48 divided by 18. Divide that out in your calculator right now. What type of answer does it give you? Decimal, which means it doesn't work. So then I do 48 divided by 9. Doesn't work. 48 divided by 6.
Oh, give me a solid number.
It gave you a solid number, so that means 6 works. So 6 is your greatest common factor.
Oh.
So it does, I don't care what number it gave me on the calculator. It just as long as it gave me a solid number, a whole number. Does that work? Excellent, excellent. All right. Do we have any other questions, guys, here on finding these?
No.
All right. All right, so now what we're going to do, ladies and gentlemen, is we're going to do what's called factoring. And factoring, I kind of describe it as undistributing. All right? basically your answers are going to look like a problem that you would distribute. And what's awesome about that, Chandler, is we can actually then check our final answers. When you get done distributing, you should be able to multiply it out and get right back to these original problems. Okay? So let's talk about how we start that. It says by using a greatest common factor. So that's your goal. Your first step is to find the GCF. So we've got 4 and 16. What's the greatest common factor of 4 and 16?
4.
4. Right?
Mm-hmm.
Okay. Do I need to write out all the steps, guys? Are we okay that
Do
4
we need to
divided
write
into
down
16?
two?
No, it's
One.
4.
Yeah.
Do we need to write them all down?
No!
We don't need to write them down.
No!
Yeah, don't even.
No!
Guys,
Don't
if
write it down.
it's the 4 words,
Oh my
don't keep
goodness.
going.
No.
I wanna see.
Right.
There's no but there's no reason to
No.
see. You should not list the factors. If this number divides into that number, you know that's your greatest common factor. So there is no factor chart to make. All right? How many D's do they have in common? None, because this one doesn't have any D's. I don't know why I've got people with calculators in their hand. Have I asked you to divide anything
No.
right now? Then put them down. So now, ladies and gentlemen, once we said they had no D's in common, your only greatest common factor is 4. So now what you're going to do is, if you notice I've set up parentheses. Your step after finding the GCF is to divide. Because that's what a factor does, right guys? It divides. So what's 4 divided by 4? 1. And so this is going to be 1d squared. What's 16 divided by 4?
4.
Now would we have to write 1d squared?
No.
No, but do we all understand now how we're getting this 1?
Yes, ma'am.
4 divided by 4 is 1. Now if I take this and I multiply it out, what's 4 times d squared? 4d squared. What's 4 times 4?
16.
Does that match what we started with?
Yeah.
Beautiful.
Perfect.
But ladies and gentlemen, this is your final answer.
Okay.
All right, greatest common factor of 2 and 14.
7.
Huh? Just 2 divided into 14.
Yeah.
So 2 is your greatest common
Oh.
factor.
Would it be negative 2 or would it be just base?
We're only going to use positive numbers, but very good question, Armando. Factors are positive numbers. Okay? For this lesson. How many x's do they have in common for x to the third and x to the
One.
first? 1x. All right. Your step now is to divide. What's 14 divided by 2? 7. Now, second hour had this, they said we're undistributing, so you're pulling it out. So if I have 3 x's, but I pulled one of them out, how many
Yes.
do I have left? 2. All right. What's 2 divided by 2?
Or what? Oh.
2 divided by 2 is 1. You have 1x.
Wait, why did you put minus?
Well, because what sign is right here?
Negative, but
That's a minus?
It's the typing capacity that I have in the computer sometimes doesn't give me a long minus sign.
The negative.
All right. Negative and minus mean the same thing. 2 divided by 2 is 1, correct, guys? We have 1x. We pulled 1 out, so do we have any x's left?
no.
And here it is.
I like this.
Now, some of you, as you go through factoring, and as I did the worksheet sitting over there, you really like to distribute, and you're getting the hang of it. It's a simple thing. It doesn't take very long to go right back through and make sure that I can take 2x times 7x squared and get 14x to the third, 2x times negative 1 and get a negative 2x. Make sure you're right.
Take the time to check.
Because you're getting the hang of that. So, always check it.
1 and 5, ladies and gentlemen. What's the greatest common factor of 1 and 5?
5.
5. No, 1.
1. It has to be the smallest number. What's the only thing that divides into 1? 1. What's the greatest? So we're going to have a 1 here. It's kind of useless, but I'll write it down for you. What's the largest number of x's that they have in common? X squared and x to the first.
1.
1x they have in common. Remember, you use the smallest x line. So, ladies and gentlemen, you have x squared. You pulled out 1x. How many do you have left?
2,
2.
or 1.
Wait, you have 2 X's, you pulled 1 out, you have 1 left. All right. Oh, yep, 3 of them. But what's my smallest coefficient out of all of these, ladies and gentlemen? My smallest coefficient is 3. Does 3 divide into 9 and 24? So guess what my GCF for those is? 3. What's the largest number of X's that they have in common? We have 5, 3, and 1. So what's the largest number they can have in common? 1. What's 3 divided by 3? 1. I had 5 X's. I factored out 1. How many do I have left?
4.
What's 9 divided by 3? 3. I had 3 X's. I factored out 1. How many do I have left?
2.
What's 24 divided by 3? And I just keep using the signs here, right, guys? I had 1 X. I factored 1 out. How many do I have left?
0.
Ladies and gentlemen, how'd we do?
Good.
Okay? You like it now. All right.
I don't like
Your
it.
assignment today, ladies and gentlemen,